Hello, today we'll be doing our presentation on the regeneration after destruction, secondary succession in Point Pleasant Park. In this presentation, we'll be looking at the ecology and succession of Point Pleasant Park over the last 20 years. We would like to recognize that Point Pleasant Park was originally an important spiritual gathering place for the Mi'kmaq people called Amentukati, which means spiritual place or place of the spirits. Point Pleasant Park is an urban park within an evergreen forest, mostly made up of softwood trees, red spruce being the most dominant species. This study started in 2004 as a way to measure secondary succession after the devastation of Hurricane Juan, a Category 2 hurricane which hit Nova Scotia on September 29, 2003. Succession describes the gradual and continuous change in species composition and community structure over time. Secondary succession happens when an ecological community is impacted by a disturbance. In this case, the disturbance is Hurricane Juan. Within this presentation, we will look at different factors to determine how the community has changed over this time period. These factors include species richness, which is the number of species found within a region of interest, total density or abundance, which are interchangeable terms which mean the number of individuals in a given species, and lastly, species evenness, which is the distribution of abundance of different species within a community. The objectives for this presentation are to look at the forest community, the density of the dominant species in 2004 and 2023, species richness and evenness to see how they have changed over time. Our null hypotheses for the following questions are that the overall forest community has not changed over time, the density of the dominant species in 2004 and 2023 have not changed over time, and that the species richness and evenness within this community has not changed over time.
Data was collected from 6 400-meter squared study sites in Point Pleasant Park, Halifax, Nova Scotia, from 2004 to 2024. All trees in each study site with a diameter at breast height greater than 2.5 centimeters were measured and their species were recorded. This data was used to determine densities in each study site of the two dominant species, red maple and red spruce. Additionally, 12 1-meter square quadrats were placed semi-randomly throughout each study site by throwing a brightly colored object over the shoulder, observing where it landed, and then repeating that process to place each quadrat. Every species of
We used regression analysis to examine variation in the total density of the forest community over time at Point Pleasant Park following the disturbance of Hurricane Juan. Our analysis revealed a statistically moderate positive relationship between year and total density, showing that as time passes, the overall density of the forest community increases. The R-squared value of 0.492 indicates that approximately 49.2% of the variation in forest density is a result of change over time, and since our p-value is very small, we reject the null hypothesis that the overall forest community has not changed over time. Let's look at how and why these changes occurred. Prior to Hurricane Juan, Point Pleasant Park was dominated by the red spruce, creating a dense forest canopy with minimal sunlight, restrictive to natural regeneration within. Roughly 70% of this canopy was destroyed by Juan, meaning in the aftermath, significant amounts of sunlight were able to reach the forest floor, creating ideal conditions for shade-intolerant pioneer species like the red maple. This aligns with the findings of Burley et al. From 2007, which show that disturbances initiate a cascade of successional stages, beginning with pioneer species, in our case the red maple, that thrive in now light-rich disturbed environments. As the Acadian forest of Point Pleasant Park moves towards its climax community, we can expect shade-tolerant species, like the red spruce, to reassert dominance with the continued regrowth of the forest canopy and the reduction in available sunlight.
we used regression analysis to examine variation in red spruce density over time at our study sites in Point Pleasant Park following the disturbance caused by Hurricane Juan, and we found a statistically significant positive relationship, r squared equals 0.11, between the two variables, showing that as time passes, the density of red spruce increases. Once again, we use regression analysis to look at the variation in red maple density over time at our study sites. And again, we found a statistically significant positive relationship, r squared equals 0.15, between these two variables, and again, so showing that as time passes, the density of red maple increases. According to Neely et al. 2011, red spruce is a climax species, indicating that we can expect it to remain well represented in the community into the future. Turchin, 2016, proposed that the current status of red maple as a dominant species is in large part due to its relatively short lifespan of 150-ish years, and that the resulting quick growth rate, which would allow it to establish itself rapidly compared to other slower growing trees. This would again be consistent with Neely et al. 2011, who characterized the community co-dominated by red spruce and red maple as being a mid-successional vegetation type seen in Acadian forests such as Point Pleasant Park, following a disturbance such as, say, significant uprooting caused by wind. They predict that this community is likely to be succeeded by one dominated by red spruce and hemlock, red spruce and yellow birch, or hemlock and yellow birch. Due to the lifespan of red spruce as a co-dominant species, and due to the current establishment of red spruce as a co-dominant species and its long lifespan of 450 years from Church in 2016, we postulate that the succeeding climax community will likely retain red spruce as a dominant member.
The species richness has increased significantly over the 20 years of research. We used a regression analysis to obtain an r-squared value of 0.6 with a p-value of 2.2 times 10 to the negative 16. We reject our null hypothesis as the p-value indicates a significant relationship between species richness and years since Hurricane Juan. This means that species richness has been on average increasing over the years. I predict that the species richness will continue to increase but will eventually plateau due to factors such as resource limitation when species have reached their carrying capacities. The second metric is Pylo's evenness, which measures how evenly a number of individuals are distributed between species. We used a regression analysis to determine Pylo's evenness had an r-squared value of 0.04 with a p-value of 0.07, indicating the relationship of evenness over the years is not significant, and therefore we accept the null hypothesis for this metric. This makes sense as evenness of communities tends to decrease as the community becomes more complex, due to many factors such as competition. However, with this relatively new succession, this community has not developed enough to have a significant trend. I predict that the evenness will continue to slightly decrease as a result of factors such as resource partitioning as the community matures.
Pulling from the trends in our data and the succession theory, we can conclude that Point Pleasant Park is currently in a mid-succession stage, as seen but with the increasing density, specifically among the red spruce and red maple, and with the increasing species richness. As an urban park, Point Pleasant Park has many other factors that impact its succession process, including anthropogenic disturbances and the effects of fragmentation. Anthropogenic disturbances refers to human activities like trampling the environment, creating recreational pathways, and causing disturbances from pet traffic. All of these things are a constant at Point Pleasant Park, compacting the soil, disrupting root systems, and impacting species composition by favoring more resilient, early successional species over those of later stages. Fragmentation refers to the ecological impact brought about by breaking large habitats, like forests, into smaller patches resulting from urban development. Unlike continuous forest landscapes, Point Pleasant Park is bordered by urban development as it's in the core of Halifax. This increases the proportion of edge habitats, which include forest edges separated by buildings, roads, and other developments, causing this habitat to be exposed to more sunlight, wind, and temperature fluctuations, all of which make them more vulnerable to invasive species and unsuitable for shade-tolerant or sensitive species like those found on the interior of the forest. As previously mentioned, Point Pleasant Park, known as Amdu Gadi, was traditionally a significant gathering place for the Mi'kmaq people who have long used and taken care of the land. In addition to the current Western scientific methodologies we use to investigate, understand, and support the science of succession and other ecological processes, Incorporating traditional knowledge and values, including those from the two-eyed seeing concept created by Elder Albert Marshall, would be valuable in supporting the recovery of Point Pleasant Park to a mature, vibrant, and dynamic Acadian forest. We could put this into practice by combining Western scientific approaches like planting with Mi'kmaq ecological knowledge that prioritizes minimal intervention, respect, and sustainability. Additionally, we could incorporate no interference zones where forest areas can regenerate without the disturbance of human influence, drawing from principles on Mi'kmaq stewardship and more. So overall, understanding Point Pleasant Park's current successional state, considering the challenges it faces as an urban park, and integrating indigenous knowledges with Western science are all valuable insights applicable to the management and recovery of Point Pleasant Park.
To answer this question, we can see that in the 20 years following Hurricane Juan, the species richness data has shown a clear increase. This trend reflects the role of pioneer species, which are the first species to be established after a disturbance. These pioneer species stabilize the soil and create conditions for other species to thrive in. Over time, the environment becomes more habitable and new species move in, leading to an increase in species richness, which is what we can see in this graph. Our data suggests that pioneer species would have been critical in driving the increase in species richness over the last 20 years.
So, to address this question, from Neely et al. 2004, we know that most of the stands of trees in the park before the disturbance were the same age. They were mature, which meant they were all quite vulnerable to damage from the hurricane winds. There weren't that many younger stands, which would have been protected by older stands from the winds. And so they argue that the wind damage may actually improve age diversity, as those mature stands that did survive will now exist alongside new stands that grew up post-disturbance. And so they recommend that this diversity be maintained in order to perhaps reduce future hurricane damage.
Did the hurricane impact some areas of the park more severely than others, and what historical evidence might support this? Some areas of Point Pleasant Park were in fact more severely impacted by Hurricane Juan due to a combination of topographical features, soil conditions, and disturbance history. In 2004, Neely et al. Found that 42% of Point Pleasant Park's area contains steep slope gradients that are more prone to erosion and tree uprooting. The high winds of Juan would have intensified these factors, increasing the severity of the damage to sloped areas or even coastal edges where root and soil systems are less stable. Point Pleasant Park soils, as described by Hotcom et al., are shallow and acidic, which make them prone to nutrient depletion and low fertility. This makes it harder for species to regenerate after disturbances like Hurricane Juan. And finally, the history of past disturbances like the outbreak of pests, the removal of forest debris, and other hurricanes make certain areas of the park more vulnerable to the effects of Juan. We would like to thank Dr. Allison Schmidt and Jennifer Amsden for their invaluable advice and support in the making of this presentation. We would also like to acknowledge that Dalhousie University, Point Pleasant Park, and the city of Halifax itself are all situated in Kijapuktuk, the ancestral and unceded territory of the Mi'kmaq people. We are all treaty people. We also recognize that African Nova Scotians are a distinct people whose histories, legacies, and contributions have enriched Nova Scotia for over 400 years.